All right, in 1.7, we're going to talk about measuring variability. So being able to describe a shape and the center of a distribution is a great start. However, there's two distributions can have the same shape and the same center, but look quite different. So look at these two. Both distributions are symmetric and single-peaked, with centers around 150. These are bowling scores, by the way. But the variability of these two distributions is quite different. So when I say variability, I'm like this. It's like there's data all the way down here and all the way over here on Earl's, but on Kelly's, her data only differs from like 90 something to right under 200. So this distance from max to min is variability, and there's many ways. Well, there's a couple ways we measure this. So the first one is the easiest. There's several ways to measure the variability of a distribution. The three most common are range, interquartile range, and standard deviation. The range of a distribution is the distance between the minimum value and the maximum value. That is, you just take the max and you subtract the minimum, and that's the range. Okay, the range is not a resistant measure of variability. It's not resistant. It depends only on the maximum and the minimum, which may be outliers. That means it's not resistant. So that's a key thing to catch. Now, we can avoid the impact of extreme values on our measure of variability by focusing on the middle section of our data. To get there, the first thing you need to do is order the data from the smallest to largest. And we find the quartiles of the data that divide the distribution into 4 groups of equal size. Quartiles, quarters, things like that. Now, the easiest thing is to do, find the median first. So you can see in the diagram, here's the median. Okay, I found the median. Here's the middle. And then what you do is you find the median of the left side, okay, of the median. All this data over here, we find the middle of it, and it's right here. We call that the first quartile. And then on the right side of our median, we find the median of that piece of data, or those data points, and it's called the third quartile. Okay? So another way you can think about it is the first quartile lies 1/4 up the way the list. Second quartile is the median, which is halfway. The third quartile is 3/4 up the way up the list. So 25% and 75%. And median, of course, is 50%. All right? So the quartiles of a distribution divide the ordered data into 4 groups, having roughly the same amount of values. To find the quartiles, arrange the data values from smallest to largest to find the median. Then the first quartile is the median of the values that are to the left of the median. The second quartile, Q2, is the median. And the third quartile is the median of the data values that are to the right of the median in the ordered list. That's what we just talked about on that previous dot plot. The interquartile range measures variability in the middle half of the distribution. That's a really key phrase. Middle half of the distribution right there. Okay? So what does that mean? The interquartile range is the distance between the first and the third quartile of a distribution. In symbols, we use IQR, and we do Q3 minus Q1. The quartiles in the interquartile range are resistant, that's important, because they're not affected by a few extreme values. Okay, important that you catch that. Now, we're going to do this real easy in the calculator, but first let's talk about the third measure of variability. If we summarize the center of a distribution with the mean, we should use the standard deviation to describe the variation of the data points around the mean. This is another measure of center. The standard deviation measures the typical distance of the values in a distribution from the mean. To find the standard deviation, and we use the symbol SX of a quantitative data set with n values. Okay, here's your keystrokes. Make sure you fill this in on your notes. Stat edit. Enter your data into list 1, then you'll hit stat, calc 1, and then calc, and then 1 variable statistics. Choose list 1, enter, hit calculate, and then from the screen you're going to see X bar. Remember, X bar is the sample mean. SX is the sample standard deviation. That's what we want. And if you scroll down on the screen, you will find additional statistics. Like you will find the Q1 and the Q3. We're going to show you that here in a minute on the calculator. So properties of the standard deviation as measured variability. Standard deviation is not resistant. The use of squared deviations makes standard deviation even more sensitive to extreme values in distribution. So it's not resistant. Okay? If our distribution has outliers, we don't want to use standard deviation because it's going to get messed up because of those outliers. Standard deviation means variation about the mean. It should only be used when the mean is chosen as the measure of center. Okay, so catch that. It should only be used when the mean is chosen as the measure of center. When is the measure of center? When do we use mean? Well, that's when it's symmetric. Okay, the distribution is symmetric, then we use standard deviation. Otherwise, we got to use another option. So the median and the IQR are usually better than the mean and the standard deviation for describing a skewed distribution or a distribution with outliers. Okay, so if it's skewed or has outliers, we use IQR and median. Use the mean and standard deviation only for roughly symmetric distributions that don't have outliers. All right? So let's look at this. How many pairs of shoes does a typical teenage boy own? To find out, a group of stat students surveyed a random sample of 20 male students from their large high school. Then they recorded the number of pairs of shoes that each boy owned. Here's the data. Find the range of the distribution. Okay, this is really easy. Remember what range is. It's just the maximum minus the minimum. All right, so look at our list here. All right, so range is just maximum minus minimum. So our maximum number of pair of shoes was 22, and the minimum is 3. So if I subtract, then my range is just 19, and I'm done. That's it. That's all you got to do. That's what if they ask for range. Now, all right, so same question, but now it says find the interquartile range and interpret the value in context. See? Minus Q1. So we're going to let our calculator do the thinking. So in your calculators, you should have the keystrokes in your notes, so just follow me for a second. Turn it on, go to Stat, Edit, and in this list 1, I've already entered all of our numbers of shoes. Then we're going to go back out to Stat, over to Calc, One Variable Statistics, and I choose list 1 because that's where my stuff is, and then hit down to Calculate. And there's the screen we've seen before. X bar is our mean, S is our sample standard deviation, but see the arrow, scroll down and look at that. It gives you Q1 and it gives you Q3. Okay, Q3 is 10 and Q1 is 5. So my IQR is just 10 minus 5. So I'm going to show my work and say Q1 is 5. So my IQR is 10 minus 5 or 5. Okay? Now, it says find the interquartile range. We did that. Now it says interpret. So to interpret this is the wording we would use in this problem. Lots of context, but here we go. We'd say the range, the middle half of number of shoes for a random sample of 20 male students is 5 pairs. The range of the middle half of the number of shoes for a random sample of 20 male students is 5 pairs of shoes. So anytime you're asked to interpret interquartile range, you're going to repeat some of these phrases, like the middle range of, or the range of the middle half of whatever it is, and the rest of it you fill in with the context and the answers of that problem. Don't use the same sentence every single time. Use the same framework or format, but you change the context. All right, so let's look at number 3. The first 4 students arrived for a first period stats class were asked how much sleep to the nearest hour they got last night. Their responses were 7, 7, 8, and 10. So calculate the standard deviation and interpret this value in context. All right, so to calculate this, go back to your calculator, hit Stat, Edit. Now I have all this data in there. The way to clear it out is go up to L1 and hit Clear. Don't hit Delete, but hit Clear. Now it's gone. So now I'm going to enter that data, 7, 7, 8. There it is. And then I'm going to let the calculator figure it out for me. So Stat, Calc, one variable, comes from list 1. All right. All it's asking me for is standard deviation. So I want the S. See how it says SX? I want that. SX is standard deviation, and it's 1.41. Keep it to 2 decimals. All right, that's the calculate part. The calculator did it. There's no work to show, but interpreting is very important. Okay, so look at this. This is the way it would be. The number of hours of sleep last night for the first 4 students who arrived in a first period stats class typically varies by about 1.41 hours from the mean of 8 hours. Now, if you're wondering how I knew the mean, well, the mean was on our first screen. See the x bar equals 8? It's right there. That's how I knew what the mean was. Okay? Now, again, it's the framework you use. You don't use exact wording every time, but you change it up. Change up the context. So I'm going to highlight the parts that you're going to use over and over. Okay? Number of hours sleep last night for the first 4 students to arrive in the first period class stats class typically varies by about whatever from the mean. Okay, the rest of this is specific to this problem. So you're going to learn a lot about writing in context this year, and this is one of the key things you got to do is be able to interpret in context using correct framework. All right, so that gives you a good idea of how to handle standard deviation, IQR, and range.